Okay, let's start numerical 3.1 of chapter conservation of momentum. So you can see, consider a gun of mass m that fires a shell of mass m with speed v. That's the shell speed related to the gun. Assuming that the gun is completely free to recoil, this means that there is no external force on gun or shell. So you have to find the shell speed which is related to the ground is these using conservation of momentum. So the initial momentum, which is 0, the final momentum, which is the sum of the momentum of the gun and the momentum of the shell, which is exactly equal, because we have discussed there the momentum should be conserved. So after arranging, the momentum of the shell will move towards the right side, which is in the negative form. So this equation shows that the momentum of the gun is in the negative direction and the momentum of the shell is in the positive direction. Both are moving opposite to each other. So this is the velocity actually of the shell, which is exactly equal the sum of these two velocities. So these u-term velocity, which is exactly the same value, which you can write with this letter and this, it's up to you. So this is the speed of the shell which is relative to the ground, and v is the velocity of the gun. Further, take this equation again and put the value of and vg, which is these. You can see, after get the value of vg, you have to put the value of vg again in this above formula, and you will get these terms. So this is the velocity actually which is relative to the ground. Okay, now further you can see, after arranging terms and putting values, you will get these equation. Take the common v shell, which is the velocity of the shell, and put in the denominator form and divide the terms individually. You will get the velocity of the shell, which is exactly equal to the velocity which is relative to the ground. Okay, thank you. Now let's go towards other numerical.